here. So today we have to do 3.5.2. Last time we had 3.5 logic circuits, and this was some of the things that we did last time. Very interesting part. Today we have to do 3.5.2, which is this example. Just skim through what we did earlier. We had a question to solve. This is the question. Produce a truth table for the following logic circuit. And we learned that you have to break it into three, just like our normal modular programming, breaking, like you all would have learned decomposition, breaking down into smaller parts. So this one, 1, 2, 3. Part 1, part 2, part 3, we broke it into three parts and then solved separately. The part 1 earlier here, then part 2 and part 3. Finally, we got the overall truth table, this. Then we had some exercises given. I hope you all would have done this. You can do it anytime, even after today's class, even you can do. And you can ask Vidushika for any help, those who missed the lesson last time, and the video is on the website. So here we come to today's one, 3.5.2, example 2. A safety system uses three inputs to a logic circuit. An alarm, which is X, sounds if input A represents on and input B represents off, or if input B represents on and input C represents off. It's like Greek, no? More than logic, it sounds Greek if you don't concentrate well. So let's read it again and see. And also we'll try to produce a logic circuit and truth table to show the conditions which cause the output X to be 1. So I'll read again. X will sound if A represents on, which means 1. No? When A is 1 and or A is true. And input B represents off. That means B is 0 or in other words, now we learned earlier, last time we learned about the logic, the notation and the Boolean algebra. So in Boolean algebra, how it sounds and the other way now. The B represents off is either 0 or B bar. We learned that the inversion of B, opposite of B, not B, and it's called B bar. Or if input B represents on, so this is another, now see or, it's another condition. Either this condition, this and that is one condition. Can you see an and here? This is one condition. What is the condition? A is 1. And this is another condition. And A and B. Or. So there is another condition which the alarm will go. Either this is true, these two are true, otherwise these two are true. If input B represents on and input C represents off. So altogether there are three inputs. So we are asked to produce a logic circuit and truth table to show the conditions which cause the output X to be 1. The first thing to do is to write down the logic statement representing the scenario in this example. To do this, it is necessary to recall that on equals 1 and off equals 0. And also that 0 is usually considered to be not 1. Not 1, the opposite of 1. Like good, not good. Something like that. So we get the following logic statement. X equals 1, and that is this part. X sounds, X sounds, right? That is X is 1. If A equals 1, This is A equals 1. If A equals 1 and B equals off means 0 or not 1. Then our big or, the separation here. Or is here. And again open brackets because there are two combination, two inputs here. What is that? Or if input B represents on, that means B equals 1 and C represents off. That means C is not 1. It's nice, isn't it? Very nice. I love it. I like it. Logic. You must always, when you think always, you become logical. They say your logic is hopeless. Has anyone told you that your logic is wrong or something? When there is an argument, when adults especially, you all don't use it. Yeah? When adults uh, argue and when one is losing generally, that one will say, your logic is wrong, man. All right. So your thinking is wrong, in other words. Okay, back to this one. So we did this. We got the statement. And the description here is, this equates to A is on and B is off. Okay, no? What we said now. You're going back here. A is on and B is off. Then this represents the two paths are connected by the OR gate. So this is like an option, either this, the left or right. This equates to B is on and C is off. That is again this one. C is off. Note this statement can also be written in Boolean algebra as A dot B plus B dot C. Now C, remember, I hope you remember these notations. Dot T is for AND, plus C is for OR. Okay, so for this AND, you put a dot here, and you take the values. Take the values of and put A dot B, whatever the values, A dot B or B dot B, sorry, A dot B bar. This is B bar. That is A and not B or B and not C. Various ways of saying, but the same logic, same result. The logic circuit is made up of three parts as shown in the logic statement. We will produce the logic gate or the first part and the third part, then join both parts together with the OR gate. So the part one, the first part is A. Now you remember, your memory should be polished now, right? So good way to do that is, without looking at the previous page, try to remember. And in future, when you read something like this, always think that this will be needed. When you turn the next page without looking back, you must remember. Then this will go into your head. A and A dot B bar. A dot B bar. And the other one is B dot C bar. So here, now combining both parts with the, so this is the diagram. Why? B, to get not B, you have to have a NOT gate. Isn't it? Now, last time we learned, Vidushika will agree. Last time we learned, we have to write like this. A and not B. So you can write A dot, because this is an AND gate. And here the B is coming out like not B, no? Oh, very nice. Excuse my freehand writing, right? AB, this is A, B bar. Like that you write. So here what is it? B and or B dot C bar. Simple. B dot C bar or B and not C. Now combining both parts with the OR gate with gives us like this. This is on. This is the OR gate. The in the middle we had, one is this condition, the other one is that condition. So this condition is A and not B, and see this part, because we need B for the second one. For the second one, we need B. So we take a connection from B when? Before or after not? It has to be before. Otherwise, if you take from here, it will be B bar. But we want just B. B, and from here C bar. So these two conditions go through this, which means one of these conditions true, the alarm will go. Any questions? You can unmute and ask questions or say anything.
So when you're connecting in the junction, like when you're connecting to a logic gate, is it important like to draw a dot?
Yes, like this, huh?
Yeah.
Not very important. You won't lose marks, but generally it's a practice. There are certain things which we can't really tell exactly how the examiner will look at it. So we have to take the safer path. Not the easier path, but the safer path. The safer path.
So I have
They have taught no earlier to do that. So because of that, we do that same way. Yes, someone wanted to say something. Naphtali?
yeah yes me sir, can't you like shorten the logic circuit, as in I drew it while you were explaining, I drew it. Can't you write it like this?
Can you give me a minute? Naphtali, 1 minute. This is going
Yeah.
to previous question of Tremolo. So this is the one that Tremolo was referring to. This dot. This
Yes. Yeah.
junction. Yes. So since they have showed us, why not? We'll do it. So without being lazy, right? So that's the answer to that. Do always do the safer thing. Yes. Now, show, Naphtali can show.
Sir, can't you draw it like this instead, like a shorter version of it?
Is a not gate there? I can't see it small, no?
Yeah, yes, it's pretty small.
So what's the difference? I think it's the same.
Sir, this one is like lengthier, as in it's the same thing, but
Now this is the final one. Huh? Is it different to your drawing? These steps, it's not necessary. These steps are for understanding.
okay.
If you draw this final one, that's it. I think you have drawn this final one, no? How many?
You don't need to draw the other steps, right?
No. That is for explanation purposes or your understanding purposes. Is this the same thing that you drew?
Yep, I think so, sir. Yeah.
Okay. Now, how many NOT gates?
2 NOT gates.
How
Can
many
you
AND
see it,
gates?
sir?
How many AND gates?
2.
How many OR gates?
1 OR gate.
How many XOR gates?
0.
0. Okay. Yeah, so this is the same thing. Okay, good. You must participate like that. You must always question and see, clear your doubts. Very good. Now everyone knows that this is not necessary. So by asking that question only, everyone got. Otherwise, all will be drawing this one by one. Okay, so then there are 2 ways to produce a truth table. Trace through the logic circuit using the method described in example 1. Right? Example 1 is earlier. Then the other step is produce the truth table using the original logic statement. The second method has the advantage that it allows you to check that your logic circuit is correct. So let's see. Now all of you know how to draw these 3 columns. If there are 3 inputs, how many rows do you need? Your turn to answer.
8.
8.
8 is correct. Anyone who doesn't agree or who is not very sure how you get 8, tell me. No. So all know about it. But I will repeat 2 to the power n. N is the number of inputs. So here we have 8 rows and columns, of course. We don't know. We'll have to, while going on, we have to do the intermediate steps, intermediate values. And do you know how to put these values? If it is 8, half of it zeros, half of it ones here. Then the next column, this is halved. Like 4 is halved, and then 2 zeros and 2 ones, like that it goes on. And finally, this is also halved of B. Half of B is 0, 1, 0, 0, right? Then first A equals 1 and B equals not 1, right? Which means sorry, excuse me. Let's see now. This is very easy like this. If you write the other way around. Oh, sorry. This one. This is very easy if you write this way. Let's see. We'll take it onto a sheet. For zeros, okay. Okay.
No,
Sir.
sir.
No.
No, C should be
No, sir,
0, 1,
0,
0,
1.
1, 0, 1, 0.
0, 1.
All right. Oh. So now the next one. Let's get this also written here. Let's see whether you can tell me without looking. Tell me what is the
A dot B bar in brackets.
A dot B. I will put this. Huh? I can't put the. Then
B dot C
Dot
bar.
C bar. N B dot C bar.
like this.
No.
No, sir.
No. A dot B bar.
Plus.
Then plus B
You are
dot
not looking
C
at the book,
dot.
no?
No, sir.
Right. Very good. Why don't you say bracket? Open bracket. Otherwise, I'll have to type again. Erase. B dot C bar.
C bar.
Correct. So let's take the first one. Now we have A and B and C, but we need B bar. So we have to calculate that first, no? B bar. The opposite of this, right? 1, 1, 0, 0, 1, 1, 1, 0, 0. Correct?
Yes, sir.
Then what do we do? We take
C bar.
C bar.
C bar also, you can take same way, or you can now calculate this also. But
A
C
dot B bar.
will be easier, yes. But later on, the columns will be closer then. C bar is 1, 0, 1, 0, 1, 0, 1, 0, 1. Oh, what happened? Yeah, 0, 1, 0, 1, 0. Correct?
Yes, sir.
Yeah. Now let's take the first part. A
A
dot
dot
bar. A dot B bar. Right? A dot B bar. That means
A and
I think that's enough. Save these two. So 0 and 1. No? First one is 0 and 1.
0.
Yeah.
Zero.
But if you,
0.
instead of doing all that, we can go to where you get 1 and 1. See, 1 and 1 is 1.
One.
1 and 1, they are also 1.
1.
And that's all. No?
Yeah.
All the others, put 0. That's a shortcut. Yeah, instead of checking everything. Until you are conversant with it, you can do one by one, which is like 0 and 1 is 0, 0 and 1 is 0. Like that you can repeat. But when you are an expert, then you will know that it is only 1 and 1 is 1. So look for those two, only two there. All the others straight away 0, 0, 0, 0 is easy. Now the other one is B dot C dash. Same way, now I have to now we have to take B dot C dash. So without highlighting, just try to do like this. 0 and 1, 0 and 0, 1, 1. Here 1 and 1. So I put 1 there. 1 and 0, 0 and 1, 0 and 0, 1 and 1. Here. All the others 0. Then A dot B dash E dot C dash. Last two. It's easy, no? Last two. This or that. So they are 0. No, let's see 1. Wherever there is a 1, it becomes 1. Okay. Let's see
Sir,
whether,
you missed one.
which one? Here. 0. Let's see the answer. Do I hear train? Are you all, is anyone staying near a railway station? I can hear like a,
No.
can hear like a train going, or like a sawmill, like some timber.
I think that's a fan. The fan.
Okay. So here is the answer. Let's see. Where is our answer? Hmm. Yeah. 0, 0, 1, 0, 3 ones and 0. Correct. Congratulations. Right. Let's go to the next one. Right. Oh, I don't know where to put you all. I'll put you all on top. Right. 3.3. Did we finish earlier? Yeah. Note, it is optional to leave in the intermediate values or to remove them, giving a 4-column truth table with headings A, B, C, and X. So here is another challenge. Some in the A-level classes, they prefer to do without these. Right? These two intermediate values, they straight away put that. But personally, I don't like that. My personal advice is to do these intermediate values for 2 reasons. One is, I myself, I'm not sure of doing without these, getting the output straight away by looking at this.